Today we're going to look at our factoring quiz for sections 4 and 5 from chapter 6, starting with number 1 here. The very first thing we always want to look for when factoring is a common factor. So with the 50a to the fourth b minus 98b cubed, we can take a 2b out of everything. Once we do that, then we can see that we actually have a difference of squares. So you'll remember that difference of squares pattern. It's a squared minus b squared. And that factors as a plus b times a minus b. So in this case, we still have our 2b out front. We square root both of these two terms here. And when we do that, we get 5a squared minus 7b. And so then we also have a 5a squared plus 7b. And so that's how we factor that first one. Again, big point there, make sure you take out the common factor first, and you can always be on the lookout for those special factoring patterns, especially that difference of squares pattern. Now number 2, there is not a common factor that we can factor out, but this is that difference of cubes pattern, which you will remember, I'm sure, is a cubed minus b cubed. That factors as a minus b multiplied by a squared plus ab plus b squared. So that's our difference of cubes pattern. Nice thing about that is we start by just cube rooting our two terms, and we get 5a minus 2b. And those are really the basis for the rest of our factored form there, really the trinomial. Because notice in that trinomial, first thing is just squaring a. Well, we already have a right here, so a is our 5a, really. So we square 5a, and we get 25a squared. The second part of our trinomial is just the product of our two, or product of ab. Well, a and b are right here. In this case, 5a and 2b. So we multiply those together, we get 10ab. Notice the sign is positive. So we really kind of ignore the negative on the 2b, we just know it's going to be plus. So again, when we're multiplying those together, it's just the 5a, 2b, not 5a and negative 2b. And then the last thing we have here is just squaring b. Well, b is the 2b, so we square that, and we get 4b squared. Alright, moving on to number 3, the 9x squared plus 24x squared plus 16 certainly looks like a perfect square trinomial. If we square root the 9x to the fourth, we get 3x squared. Square root the 16, we get 4. And if we find that product and double it, we do get 24x squared. So that confirms that yes, it is that perfect square trinomial. And again, that pattern looks like this. It's a squared plus 2ab plus b squared. So again, what we're doing right here is checking to see that when we do figure out that a is 3x squared and b is 4 from here, that 2ab matches the middle term that we have there. So again, that confirms it, and that shows us then again that our two terms are 3x squared and 4, and so this just equals 3x squared plus 4 squared. So that's not too bad. The next one, number 4, looks like there's a common factor there again of 2x this time. When we do that, we see we have 6x squared plus 7x plus 2. So it's not a perfect square trinomial, doesn't fit one of our special patterns, so we'd just be looking at factoring it, looking at the factors 1 and 6, or 2 and 3, and 1 and 2. And again, the question is, how do we get that to be 7x? It looks like we do that by doing 3 and 4. So the 2x is still out here. We do have a 2x and a 3x. Let's see, the 2x has to multiply the 2, so that has to be over here. 3x multiplies the 1, so that is there. So again, there's our completely factored form for that. Number 5. Now this one has 4 terms. That should automatically get you thinking factoring by grouping. So we'll group the first two, 15a cubed minus 20a squared b, and should already be kind of seeing what we're going to factor out of that. Now we do have a minus in the middle, so again that's where we kind of change the signs here. So we have 18ab squared. Again, then it becomes minus 18 when I distribute the minus through. We have a plus 24b cubed, so that means this has to be minus 24b cubed in order for that to become plus when I distribute the minus through. In this first binomial, we can take out a 5a squared. So 5a squared here, that leaves us with 3a minus 4b. So that kind of hints at us what we should end up with when we take out our common factor from the second binomial, where we can take out a 6b squared, and so that leaves us a 3a minus 4b. So they do match, so again what we do there is we factor out the 3a minus 4b, and then we're left with 5a squared minus 6b squared. You would want to check to see that this does not factor, again, it's that higher degree, but that doesn't factor, so we're all set there. Starting with number 6 here, we're solving equations by factoring. So really I'll be looking for both the factored form and the solutions. For number 6 we can factor out an m, and so if we do that we get 15m minus 11. It does not factor any further, so we set each factor equal to 0. M equals 0 is already solved. 15m minus 11 equals 0. We would add the 11 and then divide by 15, so m would be 11/15. So 11/15 and 0, that's what we're looking at for the solutions. And you can check those by plugging them back in. Make sure that they make the original equation true. For number 7, the big thing is that we are not really going to be able to make use of that 3x minus 9 times x plus 6. We just have to find that product so we can simplify from there and get that into standard form. So I'll go ahead and do that. So here's what we get when we find that product for 3x minus 9 times the x plus 6. We get 3x squared plus 9x minus 54 equals the 22x plus the 2. So we would subtract the 22x and subtract the 2 from both sides. And it is quadratic, so we want to make it equal 0. From there, we get 3x squared minus the 13x minus 56 equals 0. So we would be looking at factors of 50, we'd be looking at factors for the 3, so 1 and 3, and the factors for 56, trying to figure out how we can get the 13. So it looks like our combination that we would need here would be the 3 times negative 7 and the 1 times the 8. So that would factor for us as x, let's see, minus the 7 and 3x plus the 8. So again, this equals 0. So one of the solutions is x equals 7, and the other would be x equals negative 8/3. So those are the two solutions we come up with for that one. Looking at number 8, we can factor a t out of that, and then we should be able to see that that will be a difference of squares pattern. So t, and then we'd have 7t plus 8, 7t minus 8. So set each factor equal to 0, we get t equals 0, t equals negative 8/7, and t equals 8/7. Last problem we have, again, with the four terms, we think factoring by grouping. We do have that minus in the middle again, so make sure you switch that sign on the 180 as well. So now that we have those binomials grouped, we just take out our common factors. So for the 2p cubed minus 5p squared, we can take a p squared out of that. Leaves us with 2p minus 5. For the 72p minus 180, again, you can use the 2p minus 5 as kind of a guide. I know that 36 times 2 is 72, so I can see, okay, I need to take a 36 out of that. It does work out because 36 goes into 185 times. And so if I look at this, I've got a p squared minus 36. So that is one of my binomials here. And then the 2p minus 5 is the other one. So here is an example where we have that difference of squares pattern. So that p squared minus 36 factors as p plus 6, p minus 6, and we still have the 2p minus 5. And so our solutions, we get negative 6, positive 6, and 5 halves. And again, you can check all those by plugging them back in, but that's what we come up with. So thanks for watching, and hopefully that helped.